Since we've introduced the Anser forged iron, a lot of people always come up to me and say, "Hey, this is fantastic. Pink's finally doing a forged iron." But in actuality, we made a forged iron, the previous Anser iron, 40 years ago. And what's unique about that is the original forged Anser iron was also started as a forging, and Karsten and Alan and John Solheim milled in to the back cavity a large cavity design that gave it a balanced toe weight with a long hosel to give it extra inertia. And really we've carried those same design principles, those same physics principles into the modern day iron. So we think that it's unique here that we've used a lot of the same technological and physics principles in the new Anser iron that existed in the original Anser iron 40 years ago. We've just fine-tuned them with more technology, finite element analysis, design optimization to obviously achieve a performance level that we weren't able to do 40 years ago. But a lot of those same principles in the original Anser iron exist in the modern forged iron. We start off with a billet of 8620 bar stock, and we heat that up molten red, very hot, and then we use a huge forging press that's 3 stories tall, and there's a die, a negative of the final geometry that we want, that comes down and hammers that bar stock 3 times, and we have to hit it 3 times as opposed to 1, again because of the large change in thickness that takes place in the part that helps go into achieving the performance characteristics that we want. And then we just do a little bit of polishing around the part to remove the parting lines, and then that forged part is then joined with a large tungsten nickel kind of sole and back flange piece that helps give the center of gravity its location and give the part a lot more inertia so that it has the forgiveness that we want. One of the unique features, design features of the Anser forged iron is the large hollow cavity design that's right in the middle of the part. And what that does for us, it allows us to remove a lot of extra mass from up close to the face. And that helps pull the center of gravity back, which does 2 things. Number 1, it helps the ball go higher a little bit easier for the golfer. And number 2, it allows more of that mass to be spread around the perimeter, so the part has a little bit more forgiveness to it. It does those 2 things from a performance standpoint. From a feel standpoint, it allows us to have a very large, very thick face. So we have this support bar that connects directly from the face, from the impact area to the back flange, and that stabilizes the face, and that helps what goes into the quieter sound and feel of the iron. And at the same time, during the impact, it reallocates a lot of the stress from the face away from the face, so that distance control on this iron is a premium, and that's been something that we've predicted from the performance of this iron and been able to validate in our testing, is that the face is very stable and will give the utmost in distance control from any forged iron that's out there because of the stable face. Another major design and technological feature of the Anser iron is the milling processes that we do on the toe cavity, the heel cavity, and the CTP cavity. And what this allows us to do is to maintain very tight tolerances for face thickness on the part, and be able to create a little thinner geometry around the CTP cavity than could normally done with an everyday forging, because we're able to go in there and mill out that excess material. So at the end of the day, this allows us to hold very tight tolerances for face thickness, and it guarantees that throughout the life of the manufacturing that we do with this part, even if the forging dies wear and change a little bit, since we're machining that final geometry into the part, we hold very tight tolerance for the mass of the part, the center of gravity, and the thickness of the part, so that all the parts are very consistent from the very first part that we made to for the life of this project. All the parts are going to be very, very consistent. One of the major design features in the Anser iron that would not have been possible previously in forgings is the large change in thickness from, this iron has 4 cavities, kind of a high toe cavity, high heel cavity, a CTP cavity, and then the hollow cavity design here. And advancements in the forging process, the forging dies, and the forging presses have made it possible now for us to design a very large change in thickness right from the center of the part here to these 4 different cavities that would not have previously been possible. And what this has allowed us to do is put a very large support bar right through the middle of the face to stabilize the face and quiet the sound and feel, while still having a 4 cavity design to give this part a lot of inertia for both mishits on the heel and toe and high and low on the face, to make it the ultimate iron for performance and feel. FEA stands for finite element analysis, and we use it in all of our designs here at Ping, and it was really helpful for us in the design of the Anser forged iron because we used an 8620 material which has some different properties to it. It's a little softer and has a different modulus of elasticity, so it bends at a different rate. So this FEA tool allowed us to predict what the stresses would look like in the part, as well as get a feel for how much bending and face deflection takes place during the impact. And we were able to utilize that very heavily on the design of the Anser forged iron to be able to create a structure design, a three-dimensional geometry design to remove stress away from the face. And that's really the key to giving this iron a very stable face and this quieter and softer sound and feel. And all of that is made possible through the use of our supercomputer and finite element analysis. There's a lot of engineering philosophies that Karsten taught us and that are deeply ingrained into our design philosophy here at Ping for all the products that we do, and the same is very true on the new Anser iron, because we want to put a premium on the forgiveness and building the moment of inertia. And one thing that Karsten was very big into was not only providing a high moment of inertia or resistance to twisting for shots that you miss it on the heel and the toe, but he was also put a large emphasis on all his products for building the inertia in the other direction, the other plane or orientation, which gives you more forgiveness for shots that you miss hit thin or high on the face, because obviously that exists in golf almost just as much for shots hit on the heel and the toe. So with this Anser forged iron, you will notice that not only do we have heel and toe cavities, but we also have cavities that are low on the face and a little higher on the face, and that spreads the mass away from the part in all directions, not just heel and toe, and that gives the club a lot of inertia for mishits that are high on the face and low on the face. And that's something that we've tried to pay a lot of attention to in our designs that Karsten taught us and is deeply ingrained in our design and philosophy here at Ping.